In this video, we're going to start subsection 6.7.2 on the triple scalar product and the determinant. Proposition 6.7.2. If vector u is u1, u2, u3, vector v is v1, v2, v3, and vector w is w1, w2, w3, then the triple scalar product of u dotted with v cross w is the determinant of the matrix that has the components of these vectors in as rows. That's supposed to be a v, v3, and w1, w2, w3. And sometimes we write this as a shorthand as just the vectors as rows between the determinant bars. Proof. So let's go and calculate the triple scalar product like we would have back in our chapter on vectors. First, we would start with the cross product, so v cross w. We'd write out the vectors, so v1, v2, v3, and w1, w2, w3. We'd recopy the first two entries of each of them, cross out the first row, and do the cross motion. So we have v2, w3 minus v3, w2, v3 w1 minus v1 w3, and v1 w2 minus v2 w1. The next step would be the dot product. So u dotted with v cross w would be, well, vector u, which is u1, u2, u3, dotted with this vector here. So I'll copy that with technology, so dotted with this, which would give us u1 times v2 w3 minus v3 w2 plus u2 times the second component, v3 w1 minus v1 w3, and then plus u3 times the last component, v1 w2 minus v2 w1. And so expanding all of this, and we get u1 v2 w3 minus u1 v3 w2 plus u2 v3 w1 minus u2 v1 w3 plus u3 v1 w2 minus u3 v2 w1. So that is the expanded form of the triple scalar product. Now let's go and calculate the determinant of this matrix. And we're going to do this using our Saras's rule. So u1, u2, u3, v1, v2, v3, w1, w2, w3. We copy the first two columns. So u1, v1, w1, u2, v2, w2. And then we'll do our cross triple diagonal product. So we're going to get here u1 v2 w3 plus u2 v3 w1 plus u3 v1 w2 minus the other products. So minus w1 v2 u3 minus w2 v3 u1 and minus w3 v1 u2. And so we want to compare our two expansions, and hopefully they are going to give us the same. So let's look at the positive numbers. u1 v2 w3. Well, there we have that there. u2 v3 w1, u2 v3 w1 is there. u3 v1 w2, u3 v1 w2. And so now hopefully the negative products will all line up. So we have minus w1 v2 u3, which is this guy, and then w2 v3 u1, which is this one, and lastly w3 v1 u2 is that one. And so those two expansions do match up, and so we indeed have that the triple scalar product of these vectors is equal to the determinant of the matrix where the vector components are put in as the rows.